Okay, our final example here is an example of a work problem. We read here that a bathtub will fill in 15 minutes if both faucets are open and the plug is in place. When the faucets are closed, you don't have the water running, take the stopper out, it takes a full 20 minutes for the bathtub to empty. How long will it take for the tub to fill if both faucets are open and the stopper is also removed? In other words, if you want to waste water, how long will it take to flood your bathroom? How long can you let it run before you'll flood the bathroom? Okay, so this is an example of a work problem. Work, like distance, is equal to the rate of work times the amount of time put into the work. Now, very important as you're going through these problems, rate is referring to an individual. So very often, and this is the case in this problem, as you can see here, the bathtub will fill up in 15 minutes. We're given a time, but the time is an individual time. That's how long it'll take when the faucets are open. Okay, it will fill up in 15 minutes. Likewise, it'll empty in 20 minutes. It's a time, but we're actually going to use that for the rate. Time in this problem is the time that the two things, or more than two, if you have more than two things, are doing their work together. Okay, so just like with distance, we're going to set up a chart. It's going to be a work chart. So here I've labeled the two rows as filling and emptying, and also my columns with work, rate, and time. Now, work's a little more straightforward than distance, because once you know two of these things, the two you'll know will be the work and the rate. Work and the time, the rate and the time, get that right eventually. And so we want to work out those two columns and multiply them to get the work. So when we come to the rate, we're talking about time or working alone. The faucets fill in 15 minutes, so it fills one tub per 15 minutes. One tub per 15 minutes. The other way, the tub is being emptied, so it's minus one tub per 20 minutes. Okay? And then the time together, well, they're both working the same amount of time. They're both going to be contributing to filling and emptying the tub together. We don't know what that is, so we can label that as our variable t. Now, you could set this problem up with a different scenario where you started filling it, and then after a few moments, you pulled the stopper out. So then the time would be different. The emptying would be less time. But you could still come up with an expression for that. Okay, once we have our two columns for rate and time filled out, we can multiply through to get our work. And then the rule is that the total of the work, adding your works up, will always accomplish whatever task you're trying to do. In this case, it's to fill one tub. So we can write that down as t over 15 minus t over 20 equals 1. And now we have an equation to solve. That equation does have fractions, doesn't have variable denominators though, so that's always good. So we just multiply by our common denominator, which in the case of 15 and 20 would be 60. And then we go through and simplify, and really that does the problem at this point. 60 and 15 cancel, it'll be 4t. 20 and 60 cancel, it'll be 3t. 60 times 1 is 60, so we get 4t minus 3t equals 60. And so t equals 60. Now that's 60 minutes. I don't know why this problem expressed the time in hours at the end as far as the answer key, because everything else was in minutes, and they didn't tell us that our time had to be in hours. So 60 minutes is a perfectly fine answer.